Hello, friends. We are podcasting Algebra 2, Section 2.5. We are talking today about direct variation as opposed to inverse or joint variation. Direct variation is simply y equals mx plus b formula where the y-intercept is always going to be 0. So these are concepts that should be very familiar to you. We're also going to have this new thing called a constant of variation, and this should look suspiciously like the slope. It is the slope. So we are talking about in direct variation, slope-intercept form where the y-intercept is 0, and we're going to call the slope the constant of variation. All right, so let's look at some problems. Here are the sort of details. A big part of what we're doing here is just identifying whether an equation, a mathematical model, if you will, is actually direct variation or not. And direct variation is something simple as, working. If you make $10 an hour, if you work 1 hour, you get $10, 2 hours, $20, so forth. That's direct variation. And the constant of variation is how much you make per hour. So that would be A. They vary directly because you can just multiply whatever the x variable is by the constant of variation and get the y component. And the good thing about these lines, when I go to graph them, they're all going to go through the origin. All right, typical of the homework problems right here. Write and graph a direct variation equation that has negative 3, 2 as a solution. So I know if it's direct variation, it's going through the origin. So the point 0, 0 is on the line, and they give me a second point. So I could just take those 2 points and write an equation for a line the way we always have. But I also know that this is the x coordinate, this is the y coordinate, and if I plug those in, I can solve for A. So another way to think about it, even easier, is if they give me direct variation and a point, I just put the y variable on the top of the fraction, the x variable on the bottom, and that's my A. That's the constant of variation. And typically what they'll ask you to do is then they'll give you a point, some other x value, and ask you to find y when x is whatever. But before we get to that, let's just do this. Pause the podcast, write an equation, and graph this line. Once you got that going, you can get a little preview. This is what the homework's going to look like. And more of the same. They're going to give you an x and a y and ask you to write in a direct variation equation. Then we're going to get to this type of stuff where I'm just asking, is this equation, is this mathematical model direct variation? So I'm just going to rewrite it slope-intercept form, and all I got to know is that it's y to the first power, x to the first power, and the y-intercept is 0. If I have any kind of exponent, or if I have a y-intercept, not so. So you should be able to tell tomorrow, tell me in class, which one of these is and is not a direct variation model. More of that. Okay, so you can see the homework's not going to be terribly challenging. And then we come to uh, direct variation word problem using Hooke's law. I want you to pause the podcast, read this, make sure it makes sense to you why the numbers are in here. And then we got a practice problem, same sort of idea from example 2 right there. All right, so you should be able to pause, try that one out. And then last but not least, we have these more interesting ones, which say if it's direct variation and I'm given a table of data, so notice no equation, a table of data, the ratio between each x and y should be about the same. And remember I told you in the real world, very few things come out exact. So in this one, they take each x and put it over its corresponding y. And they get a ratio. And 0.35, 0.35, 0.35, 0.35, this one's 0.34. So they're all really close. They're either exactly 3.5 or they're real close. And that's what it says down here, that this is a sort of real world model for the total cost and minutes used. And the constant of variation here is going to be 0.35, 35 cents. So they want you to do the same thing here. You're going to take each x and write it over the y and get a decimal. You're going to love this, Xander. All right. And if those decimals are all very close, similar, then it is direct variation. And whatever that decimal is the constant of variation. And if they're all different, then you just plain old don't have direct variation. All right, so we'll pick this up in class tomorrow. Good luck.